we're going to go. All right, we'll be back to workers and resources in a moment. All right. Welcome to the L70, NRL 70, ULA, NRL 70 launch coverage here. Launching on a Delta IV Heavy rocket from Cape Canaveral Space Force Station, Slick 37B, Space Launch Complex 37B. And the last launch, if it goes today, the last launch of Delta IV Heavy, closing a chapter of, or closing a book of the U.S. space program spanning back to the 1960s. Yeah. Hi, I'm EJ. I'm your host today. As if there's any other hosts on this stream. Anyway, so yeah, last one. It's been a pretty awesome ride. This is it's bittersweet. It's bittersweet with L70, with the L70 mission. Delta IV has done a lot of crazy missions over the years, including launching test flights for Orion. All types of payloads for the Department of Defense. Delta Rockets, the family of Delta Rockets, has launched rovers to other planets, and all manner of telecommunication satellites for the commercial market over the years. Once again, the Delta program and the Delta series of rockets goes back to the early 1960s, which is pretty crazy. So, anyway, 63 years of Delta. Yep. I was okay, and then ULA posted this video. All right, let's see. Here, maybe they'll say it better than I could. In terms of Department of Defense launches at 415, they will be handled by Falcon 9, Falcon Heavy with SpaceX, and Vulcan with ULA. So, all right. Let's see.
Following more than 60 years lifting historic missions to space and becoming a pillar in American rocketry, the Delta program is coming to a close with its final launch. Here's a look back at some of the groundbreaking firsts and iconic missions launched on Delta rockets. Delta quickly established its record of excellence in the 1960s, launching Echo, the world's first communication satellite, Tyros, the first space-based weather observatory, and NASA's Pioneer and Explorer scientific spacecraft. The introduction of the Delta II rocket on Valentine's Day 1989 ushered in the GPS era and a capability that improves life on Earth every day, from navigation to banking, agriculture, and beyond. The beloved Delta II earned its place in history with 155 flights, with 8 of those missions to Mars for NASA, including the Spirit and Opportunity rovers. The Delta program's commitment to vehicle improvement to meet customer needs culminated in the Delta IV family of launch vehicles with a wide range of increased capabilities. Delivering missions for the Space Force, National Reconnaissance Office, NASA, and commercial clients, every Delta IV launch has been successful. As America's trusted heavy lifter, the triple-barreled Delta IV Heavy launched the first Orion spacecraft on an uncrewed shakedown cruise and sent the Parker Solar Probe to surf the atmosphere of the Sun. The 16th and final flight of the Delta IV Heavy rocket carries NROL 70, capping off the incredible legacy of this program.
So, the Delta program has some heritage behind it. I like how they didn't talk about Delta III. Artemis 2-3 is going to fly the ICPS, which is a modified Delta IV second stage, right? Yeah. Yes, it is. I personally think that SLS is Delta V. Now, let me tell you why. And I was actually segueing into this. The Delta family of rockets. So, Delta families of rockets are measured by an 8-digit number. At least that's how they started to be. The original Thor missiles didn't really have a designation too much, but there's Delta 1000, 2000, 3000, 4000, 5000, 6000, 7000, 8000, 9000, right? So let me show you a quick picture of the Delta family of rockets. So originally, the nomenclature here, if you go on Wikipedia and you look at the Delta family of rockets, there was Delta A, B, C, D, blah, 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 blah. There's all different versions. These are all Delta 1s, but they carry serial number 4-digit numbers. So, yeah, see, McDonnell Douglas introduced the 4-digit numbering system in 1972 to replace the letter naming system. All right? So check this out. There's 0, 1000, 2000, 3000, 4000, 5000, 6000, 7000. Now, Delta 1 series of rockets marks slight modifications to Delta 1. 0 through 6000 is slight modifications to a Delta 1 booster. The cast, or that thing, did talk about Delta 2s being introduced in 1989, and they were. Delta 2 is technically a 7000 series Delta. Note the naming convention, 7326-10, 7425. The numerical digits here are indicating different payload fairings and different differential amounts of rockets, solid rockets. Now, the Delta 3 rocket here is the 8000 series. It only launched in one configuration, 8930. That's it. But
Discovery, go at throttle up.
it did launch. It only had one configuration. Now, for Delta 4, these ones over here, Jasper, 513 sub. These ones right here, those are Delta 9000. That's what Delta 4 is, 9000. It's over 9000. Now, they didn't keep going with the numerical naming system. There was Delta 4 medium. So Delta 4 could come with in a medium or a heavy variant. Heavy variant obviously is the 3 boosters. You guys know about that. That's what's launching today, and it's the last one. These other series here were phased out over time. Delta 4 could have 3 technically, different type of payload fairings, 2 different types of upper stages, and could have attachable solids here with all those different configurations. So you could have medium, Delta 4 medium right here, which was a common booster core, or CBC, with a 4.5 meter Delta cryogenic second stage and a small payload fairing. You could have Delta 4-2, which is Delta with 2 attachable solid rocket boosters, same upper stage, same payload fairing. And then you could have 5-2, which is the 5 meter Delta cryogenic second stage, which is flying on heavy today, with a much bigger fairing, right? And then you could have 5-4, right? So CBC, 4 SRBs, 5 meter upper stage. And then you have heavy. Heavy has the biggest fairing, hence 3 different types of fairings, and it's 3 CBCs all put together. Right? Those are all the different variants. So 4 medium and 5 medium were phased out. WGS-10 was the last 5 medium launch. That was a couple years ago. But, so why do I bring this up? Why do I bring this up about SLS being a Delta family of rockets? So SLS has a 5 meter Delta cryogenic second stage, DCSS, derived upper stage called the Interim Cryogenic Propulsion Stage, or ICPS for short. It is a Delta 4 Heavy derived upper stage. Now, per Delta's naming convention, all right, so what indicates different class of rocket? Well, Delta 2 to Delta 3 here, if you look, there's some interesting differences here. A Delta 3 is just a Delta 2 with a Delta 4 stage stacked on top of it. That's what it is. Cut down first stage. But if you notice the similarities from here down and from here up, per McDonnell Douglas / Boeing's own numerical naming convention and how they go through like different classes of rockets nomenclature, right? You can have Delta 3, which is a Delta 4 with a Delta 2 first stage and boosters attached to it, and that keeps the Delta naming convention, right? Because that's what it is. If you look at a picture of a Delta 3 rocket or a Delta 8000 series rocket, right? It blatantly has a Delta IV cryogenic second stage on it. See that? That looks a lot like that. Looks a lot like that. Looks a lot like the same thing. So, because of this, I would call SLS Delta 10,000. That's Delta 5. Because it has a Delta-derived second stage in it with a whole different booster mechanism below it. Per Delta's own naming convention, it counts. It counts. SLS is Delta 5. I don't care what anybody says. You'd be wrong. But SLS is a shuttle-derived launch vehicle family, just like pieces of the Delta family and still the DCS. Yeah, Delta 4. If Delta 4 is enough to keep the naming convention by a second stage that flew basically 3 times on a Delta 2 second stage, if this was enough to keep the Delta naming convention, SLS is enough to keep the Delta naming convention. Why? You said it's shuttle-derived. You said SLS is a shuttle-derived launch vehicle. What is this? RS-68As are expendable variants of shuttle engines. And is Delta 4 not orange? Does it not carry the same spray-on foam insulation? And similar detached tanks, no common bulkhead, inner tank design? Looks awfully similar to me. Technically, Delta 4 is based off of the Japanese H-2 rocket, but the Japanese H-2 rocket is based off of information about thermals and fully cryogenic propellants learned from the shuttle program. SLS is a Delta rocket. I don't care what anybody says. No, I will not be taking questions on it. But the Delta family of rockets has served pretty dang well over the years. There's never been a Delta 4 launch that went wrong. Ever. 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 Now, Delta 3, we don't talk about Delta 3. Delta 2 had some anomalies from time to time. But, hey, Paul Scambates with the raid. Ray, 42 viewer raid. Thank you very much. Who are you trying to prove? Who are you trying to prove to that SLS and Delta are in the same family? Anybody that wasn't aware of it? What's up, Paul Scambates Raiders? That's my buddy Ray, guys. Thanks for the shout out mods. Yeah. If you like Scambait streaming, Paul Scambates is the guy. He's a good dude. Thank you very much, Ray, for the raid. I appreciate it, man.
Discovery, go and throttle up.
Laserman, 26-month resub. I would say that Delta 5 is a good name. Yep. Why doesn't SLS use RS-68s? Human rating. RS-68s are not human rated. And to basically human rate an RS-68, you would need to basically make it a shuttle engine per NASA, right? Don't need to convince me. I'm not trying to convince anybody. I'm stating.
Discovery, go
Hey,
and
Carlos Pendrasoli. That was 10 subs. Thank you very much. Very much appreciated. Yeah, but doesn't the shuttle get a lot of its basis from the J2? RS-25 is derived from stuff learned from the J2, but it's not the same engine. No, it's a clean sheet design based off of what they learned from the J2. Tessa. Japanese H-series rockets also part of the Delta family. Well, technically by that logic, Delta is H-2 derived. But yeah, I think there's enough crossover here with the Delta family of rockets to warrant SLS be carrying the torch of Delta rockets' legacy. How did they human rate Merlin engines? There's a bunch of different criteria, Zarby. Between engine performance and a bunch of other things, dude. Launch vehicles too. Like a human rating aspect of your launch vehicle is making sure you don't liquefy the crew up on the way up. So throttleability with your rocket engine, so you don't kill people on top by basically smushing them under the G load. That's a pretty good one. Just off the top of my head. Is the EUS Delta derived? I don't know. It looks like it is. It looks like it's just a scaled up version, but who knows? We'd have to ask. But yeah, the Delta family of rockets I think is really cool. It's served a lot. It's done a lot of work over the years. Served a lot of purposes over the years. Yeah, Hellfish, it makes sense. It makes sense. Can't wait for the ignition of the L3 Harris Aerojet Rocketdyne RS-68 main engines call. Yeah. Top 5 Delta 4. My personal 2 favorite Delta 4 missions are Parker Solar, because I stood next to that rocket, and EFT-1, the Orion test flight mission. And Vulcan is Atlas 6. That's correct. Yep. Mm-hmm. Who made this graphic blue instead of orange? I don't know. Someone. Yeah, EFT-1 was an awesome mission. That was a good time. Current and forecast conditions are close to the threshold for acceptable criteria. I like how Delta 4 used to go full metal on ignition. Yeah. But you get to lick it? I mean, I wouldn't, but you could. You could. It's possible. So, ULA should be starting up the coverage here momentarily. Here we go. All right. Oh, yeah, Flagon. Yes, they do. Yeah, it is live. It is. Let's just make sure we get up to speed here and go. So, yeah, you know, current conditions down at the Cape are maybe. We'll see. Delta 45, the Space Wing Delta 45 gave us a 30% chance of go, which is 70% no go. So we'll see. We'll see what happens. But still not going to stop us from getting the coverage. Also, just on a quick side note, there is a Falcon 9 launch tonight. Launching. Oh, guess what? Guess what it's launching? It's launching Starlink. Yep. Okay. Yep. Cool. But I wanted to make a thing here to talk about Delta and proclaim that SLS is a Delta rocket and go from there. Yeah, Juicebot, we'll see. It's very maybe weather out there. It is raining. Dude, it's raining up the entire eastern seaboard right now, Juicebot. I have the same weather right now. But anyway, I'll pick up the cast here and we will...
Box foundry valve cycle test.
All right,
Roger.
Let's go.
L minus 21 minutes.
Something like that, Havix. Delta 3,
Fuel
that's
2,
silly.
perform second stage LH2 foundry and valve cycle test.
What was
Roger.
the predecessor and successor of Redstone? Not Delta rockets.
LOX 2, perform second stage LOX foundry and valve cycle
Because
test.
Roger.
Delta rockets. This is Delta's time. So the rocket is fully fueled. You can tell because of the way it is. No, the condensation coming out of the ullage vents, basically gaseous oxygen that's a result of boiling propellant.
Since 1960, Delta rockets have been an integral part of
are
America's space
condensing
program.
the atmosphere.
The
That's what
on-orbit assets
the
it has
smoke is.
launched have improved life across the globe. Let's take a look.
Following more than 60 years
Hey, we just
lifting
watched this.
historic
Oh,
missions
look
to
at that.
space and becoming a pillar in American rocketry, the Delta program is coming to a close with its final launch. Here's a look back at some of the groundbreaking firsts and iconic missions launched on Delta rockets.
They have control
Delta
of
quickly
6, so-
established its record of excellence in the 1960s, launching ECHO, the world's first communication satellite, Tyros, the first space-based weather observatory, and NASA's Pioneer and Explorer scientific spacecraft. The introduction of the Delta II rocket on Valentine's Day 1989 ushered in the GPS era and a capability that improves life on Earth every day, from navigation to banking, agriculture, and beyond. The beloved Delta II earned its place in history with 155 flights,
Delta
with
II
8
is a
of those
great
missions
rocket,
to
man.
Mars for NASA, including the Spirit and Opportunity rovers. The Delta program's commitment to vehicle improvement to meet customer needs culminated in the
Discovery,
Delta
no
IV
throttle.
family of launch vehicles with a wide
What's up,
range
man?
of increased capabilities. Delivering missions for the Space Force, National Reconnaissance Office, NASA, and commercial clients, every Delta IV launch has been successful. As America's trusted heavy lifter, the triple-barreled Delta IV Heavy launched the first Orion spacecraft on an uncrewed shakedown cruise and sent the Parker Solar Probe to surf the atmosphere of the Sun. The 16th and final flight of the Delta IV Heavy rocket carries NROL-70, capping off the incredible legacy of this program.
Anyway, Phil, you said someone asked about the future of Slick 37 during the NRO press conference yesterday, and the person from the 45th Space Wing said between the lease ULA has and the environmental impact survey, it will take about 2 years until they can start making decisions about the future of the pad. Oh. Oof. Yeah, something tells me it's not going to take that long, but we'll see. Okay, Sea Kraken, what happened to Delta 3? Delta 3 was a evolution of the Delta 2 rocket, where basically what they wanted to do was give Delta 2 a cryogenic second stage for better performance. So they put what's called a Delta Cryogenic Second Stage, or DCSS, on top of a Delta 2, a cut down Delta 2 core with boosters on the with all the solid rocket boosters. That's an RL-10B. Hey, Ev stood right there. That's really cool. Yeah, it didn't work very well. Three Delta 3s launched, 2 of them failed. And then they said, screw it, we'll just move to full Delta 4 architecture.
All things to be extremely proud of.
The first launch, you kind of kept your fingers crossed and your toes crossed. We all stood out in the main part of the factory here and watched it, and it's just something that you do and say whatever makes you comfortable for that very first launch.
Watching the Delta IV Heavy right outside the door of the Delta Operations Center and feeling the vibration and just amazement.
I was at the launch site in the dock for the NRL 26 mission.
Delta
and
Operations Center.
The experience when that thing lifted off of the acoustics, hitting that facility and literally seeing the windows flexing from the acoustics of that liftoff was something I will never forget.
I've been down to the launch site, been on the pad, been on cranes up and down a heavy vehicle, been able to support on console, and been part of the day of launch activities. So I've seen it from a unique perspective. Those memories will always stick out.
We took a lot of lessons from Delta. Aluminum skins, machined, brake formed, welded together with friction stir welding. The first time we used that was on the Delta IV program.
One lesson learned from Delta IV that will stick for our future launches is our record of mission success and our focus on mission success, making sure that all of our launches accomplished what we wanted and delivered the payload for our customers.
The teamwork that we built across all the different suppliers and across the program itself. It's a really complex vehicle, and so being able to bring that whole team together and deliver Delta for that many years has been brought over into the Vulcan program and will continue to live on.
Whether it be in the design center, the operations center, the production center, we're all a big team, and those teams work together, and it's magic.
Launch conductor is only one little cog in the whole process. This is a team sport, and the team has done nothing but a phenomenal job.
Taking pride in your work and treating everything as if it's the most important job you'll ever do is something that I will keep with me for the rest of my career.
This is really nice.
Well,
to
it's
have
bittersweet,
all
of
the
course.
old school Delta engineers.
We all thought we could do this a lot longer because we love it so much.
It's been a wonderful rocket to work on over these years, and I'm going to miss it.
It is the most amazing rocket I could ever imagine, this Delta IV Heavy.
I'm just proud to have been a part of this team and was able to better my career by working alongside an amazing team.
The legacy of Delta will live on in the Vulcan rocket and in the people that make it a reality and have taken the best of what Delta has accomplished and carry that forward into the future.
So I think it's pretty cool that they're doing all this tribute to Delta. Something that I did want to touch base on here real quick.
ASTS established scan pattern 140. Roger. VSE, verify base bending moment. Instrumentation is active and data is valid.
BBM is fully mission capable. Recommend Placard 6 Alpha for launch.
Roger. OS, set BBM active.
Discovery, go at throttle up.
Roger.
So, something that I wanted to touch base with Delta is that the Delta IV rocket and the decision from going from Delta 3 to Delta 4 to make an all Hydrolox rocket, right? So Delta 4 in the first stage, you have common booster cores. They're called CBCs. There's 3 of them right there, right? They're all Hydrolox. They're hydrogen and oxygen. And then the second stage is also hydrogen and oxygen. Now, are hydrogen and oxygen first stages the best for first stages? No, not really. Hydrogen is very efficient, but it doesn't really give you the best explosion. Like, you don't get a very energetic explosion out of it. I mean, you can. Anything is possible, right? But generally, you don't see Hydrolox first stages here. You don't see hydrogen and oxygen first stages. The reason why McDonnell Douglas and Boeing decided they wanted to do full Hydrolox first and second stage is because they were trying to make a singular propellant. If you have 2 propellants loading up, that's more stuff that you have to deal with. You only have to fill up 1 fuel tank and 1 oxidizer tank to fuel everything on this thing. Hang on, I'm going to unmute this part.
Godspeed, Chip. MD out.
So, the reason why is because Delta 4 was built to compete against Atlas 5. That's what it was built for. It was built to compete against it. Delta 4 and Atlas 5, the circumstances through which those came about was because of the expanding commercial market in the 90s. The dot-com era, she's blowing around in the wind. The dot-com era basically increased the demand. It spiked the demand for launching telecommunications satellites into space. So Delta and Atlas were built in anticipation of that crazy market. They were built in anticipation of being launched, not as much as Falcon, but almost as much as Falcon 9. 12 launches a year, 13 launches a year. That's a lot of payload. That's a lot of payload up into space. Now, I mean, I get it. Falcon launches 13 times in a freaking month, right? Don't worry, this isn't the launch. The launch is in a hold. Look, if you look at the top left. This is just replay from the last launch from Vandenberg. Now, if you look at how Delta is put together, the Hydrolox first and second stages in common booster cores actually makes perfect sense. Delta was designed to be put together fast. If you look at the Delta integration building, right? That's the flight profile here. We'll see that when it actually goes. If you look at the Delta integration building, Delta and Atlas were both designed to be launched a lot. And I think that's very interesting. The reason why I think that's interesting is because, okay, let's look at Delta's integration building here, the horizontal integration building. If you guys notice, from the start, it was built as a double integration bay. And then anticipating a lot of Delta launches in the future, they built a third one. There's 3 integration bays here. You can have 3 Delta rockets in processing flow here. I know because I've walked inside of this thing. I've been inside of this building. Don't ask me how, where, or when. I've been in there. Okay? You can support up to 3 Delta operations all at once. Now, Delta only has 1 pad on the East Coast. It had 1 pad on the West Coast. It's Slick 37B. But you can tell here from this horizontal integration building that Delta was designed to launch a lot. And if you look at how all the integration architecture goes together for a Delta booster, how they put the thing together, how they stack the thing, right? How it's integrated onto the pad, you can really tell that Delta, anticipating that crazy market share, or the crazy amount of rocket launches that were going to happen in the 90s, was really built to be put together fast. And that's part of the reason why they went with unified propellants, like hydrogen and oxygen in first and second stage, right? There you go. Havocs. So, what happened? $400 million sticker shock. Similar to how the VAB has multiple bays, sort of. So, here's what happened. The dot-com bubble burst in the late 90s. And demand for rocket launches went from launching 13, 14 times, 15 times a year to maybe once. The market collapsed. It clapped so hard that Boeing, McDonnell Douglas, and Lockheed were basically, there was no point in building rockets anymore. There was no point in doing it. Like the market it wasn't even profitable anymore. And part of the circumstances in which ULA was formed part of the reason why ULA exists and why they have Delta and Atlas rockets and now Vulcan, Delta and Atlas mostly, was because the market collapsed so hard that the only way to keep the launch market stable for Uncle Sam to launch Department of Defense payloads into space was to make one company and put all redundant dissimilar architecture under that company. And that's exactly what happened in the mid-2000s. That, and there was a little bit of industrial espionage that they caught, but so part of the reason why ULA exists is from the launch market drying up. Why does Delta have a sticker shock so much? Well, because if you have a rocket with its entire integrated architecture that's designed to launch once a month, and you end up using that architecture, all that stuff, and all that architecture that you paid for to launch once a year, the price tag will go up. That's what happened. And that's what I mean when I say Delta walked so Falcon 9 could run. Because Delta and Atlas V and Delta II before that were really the rockets that were trying to pioneer high launch cadence, low cost. Something that Falcon 9 ultimately achieved. Now, don't get me wrong, Falcon 9 didn't do it because of Delta. It's having the perspective about that and having the perspective about launch markets and how they work. That's what made Falcon 9 so successful. SpaceX knew, good and well, that they couldn't rely on the launch market to keep Falcon 9 flying a lot, so they made their own with Starlink. That perspective is why Falcon 9 ultimately is doing what Delta and Atlas originally set out to do 20 years ago. That's what I mean when I say Delta could walk so Falcon could run. But anyway, I'm going to the go, no-go poll.
Umbilicals. Go. Has gas. Go. ECS.
Go.
Red lamp monitor.
Go.
Mechanical engineering.
Go.
Quality.
Go.
Op safety manager.
Go.
UA safety officer. Go. Vehicle system engineer.
Chat.
Go. Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicle is ready to launch.
Mission director.
You have permission to launch.
All right.
Proceeding with the count. ALC. Verified T0 is set for 18:45:000.
Verified.
Okay.
MEQ. Establish swing on lock pins. Pull.
Active.
Polling is complete and the team is go for launch. From T-minus 4 minutes until liftoff, you'll hear Scott Barney and the team performing the final steps in the countdown procedure. Several critical activities occur in the final minutes before launch, including verifying fuel tank levels and pressures in the 3 boosters and the DCSS, in addition to arming the flight termination system. At T-minus 1 minute, the Range Operations Commander confirms the range is in a green condition for launch. At T-minus 15 seconds, the launch table HBOs at the base of the rocket are ignited to burn off excess hydrogen. At T-minus 7 seconds, the starboard engine is ignited. At T-minus 5 seconds, the port and center engines are ignited. Once the Delta IV Heavy lifts off, you'll hear flight commentator Rob Gannon providing launch vehicle ascent data.
Guys, I'm going to run ads so people don't get ads during the launch. We'll do pre-rolls now. Yeah, the volatility of launch markets is why Delta carries its heavy price tag havocs, and that's important to understand that perspective. Hey, there's the Delta integration building, the 3 bays right behind it. See it over there? Also, I don't know how keen-eyed some of you are. Where's Delta's flame trench? Not a lot of people know this. The flame trench actually goes underneath the tracks where that horizontal or the mobile service structure rolls. It goes under and then it ejects out over here somewhere. If you notice, the terrain over there is all scorched. So Delta's flame trench actually goes underneath the pad and turns out that way. Not a lot of people know that. I think that's super cool.
T-minus 3 minutes and 58 seconds.
LC switch not ready. All personnel go to recycle steps for operation 90.
Uh-oh. That's a hold. Pretty sure. United Launch Alliance is the operator.
LC switch is not ready.
Flight control is ready to set clock to T-minus 4 and holding.
Roger. ALC, reset countdown clock to T-minus 4 minutes and holding.
Roger.
There is a payload involved, XP. It's Delta 4's last mission, dude. But it looks like they've entered a hold.
LC flight control, SS BAP inactive, and SCS in pre-flight mode.
Roger.
They're recycling the vehicle to a 4-minute hold position. This is a picture from the Delta Operations Center.
And properly evaluate LOX recycle and report if ready to recycle.
Roger. Red line that we've...
Oh. Ooh, RLM is reporting something.
OSM, place the SRM ignition switch to disable position.
SRM ignition disabled.
ALC, count. Disregard.
LC countdown clock has been reset to T-minus 4 and holding.
Roger.
There's a long window
For
today,
step 90,
guys,
all
so
stations
just chill.
recycle systems back, T-minus 4 holding in configuration. Recycle occurred at T-minus 3 minutes, 58 seconds.
Yep.
Report status at completion.
So, you have a red line monitor report, so RLM reported something, and the count Delta auto sequencing systems held the count at T-minus 3 minutes and 58 seconds, which means that there's a condition on the vehicle that the Delta computers don't like.
Yes.
Go.
Substat Juliet, MTS safe and external.
Roger.
LC locks 2.
Go.
Second stage LO2 conditioning active.
Roger.
Okay. They're putting...
LC locks 1.
Go.
CBC locks conditioning active.
Roger.
LC ECS.
Go.
ECS set point stable.
Roger.
LC field 2.
Go.
Second stage LH2 conditioning active.
Roger.
LC SYS.
Go.
GC3 ready.
Roger.
Launch control systems. So...
LC has gas.
Go.
Step Foxtrot has gas ready. And as MEQ, should I reinstall lock pins?
Yes, let's install pins.
Roger.
They're safing the vehicle, guys. They're saving it. It was in launch condition. They put it into launch condition.
LC AV.
Go.
And the computers immediately
First
said no.
step Papa. Vehicle external.
Roger.
Vehicle switched to external power.
LC Prep 101.
Go.
All systems are stable.
Roger.
What does a red line monitor do? A red line monitor has all the telemetry in front of him and all the sensor conditions. And if one of the sensors turns red, they report it. Basically, it's like master overwatch of all the different systems. If one of the systems goes red, the red line monitor reports it. Red line monitors are why... red line monitors are important to have. I can give a good example as to why. The SLIM launch. The Japanese probe that landed on the moon, it is still alive somehow. It survived 2 lunar nights now, which is hilarious. Yeah, they reestablished contact with it. A red line monitor is there to indicate, to basically watch, eagle-eyed watch the telemetry and make sure that nothing goes out of bounds, right? For instance, with SLIM, when it was doing its landing, one of the engines went to 400% of rated thrust, causing a red line condition. Basically, the screen, that's it in the movies, when you're watching the movies and the screen flashes red and the guy's like, oh no, like, I mean, obviously he's not going to say, like, oh no, but you have a red line monitor to watch in case something is overperforming or something is not within, like good conditions to launch. With the case of SLIM, the engine hitting 400% thrust means that it probably exploded. But SLIM somehow was still able to land on the moon with one engine and then tip over and crash and still is online for whatever reason. But yeah, red line monitor is there to basically watch if any of the launch commit conditions go red. It's basically an extra set of eyes looking over all the telemetry to make sure nothing goes out of bounds.
GELC.
G.
Verify TISR status for India.
TISR ready.
Roger.
No, Sea Kraken.
All right, team. We've given direction. Recycle is now complete. We get direction to proceed into detanking.
Oh, detanking. That's the end of that. Scrub for the day, dudes. They've entered detanking procedures. CCLS. Computer-controlled launch system. Yeah, the computer said no for whatever reason.
Okay, for the team, we'll be or standby.
Hold on.
This is Delta Mission Control. It's confirmed that we will not continue with the NROL 70 launch activities today. We have a 24-hour recycle. Our next launch attempt will be tomorrow at 1:37 p.m. Eastern. For up-to-date information, please visit ulalaunch.com. I'm Andrea Linhoff. Thanks for joining us.
Okay, so... Oh boy. Okay. You got to figure out why Delta said no. So, one of the first things that they do when they put, like, this is most launch vehicles, one of the first things that happens when they put it into auto sequencing is they cut power from it and they flip on the programs in the avionics to run the ascent trajectory and run the, you know, the launch, right? There's not like a guy hitting a button that's like, haha, launch, right? Soyuz still kind of does that, actually, believe it or not, but it's turning a key. And it's more tradition at this point over there. So basically when they put the vehicle on internal power and start the sequencing program, one of the first things that most rockets do is just check everything. The computer just runs down all the sensors on the vehicle, making sure, you know, it makes sure that all the propellants are at the right temperatures, the quantity of propellants is correct, make sure the engine's at the right operating temperature, you know, etc., etc. It's basically doing a health check, right? They had a hold initiated at T-minus 3 minute 58. So 4 minutes is when Delta, at T-minus 4 minutes, it's when Delta does auto sequence, right? It's when it basically starts up and gets ready to go. And then, you know, in an ideal scenario, it launches. But them basically pressing the run Delta 4 ascent.exe go. They don't use Windows, I'm pretty sure. When they went to run that, Delta after 2 seconds immediately said no. So what does that mean? That's a vehicle condition, guys. It's not weather. That's something on the vehicle that the red line monitor caught with the launch control system. So something that, yeah, that's vehicle health. That's not weather. Usually. Yeah, a weather condition. They wouldn't have gotten to auto sequence start if a weather condition was holding the launch. So it looks like the conditions were clearing up. This is something with the launch vehicle. And once again, this happens because of infrequency of launch. Which kind of stinks, but yeah, hey, there's, you know, this phrase gets thrown around everywhere in the spaceflight industry by everyone. There is 100,000 ways that this can go wrong and only one way that it can go right, you know? So waiting 24 hours in the scheme of things is not that big of a deal. Just give it some ibuprofen. Yeah, well, I tried that yesterday with Malders and it didn't work, so. Thank you for sharing the launch process, but also diving deeper into the explanations. Yeah, no problem, Canuck. I got you. That's what I do. So yeah, they found a commit, what's called a commit condition, or Delta's computer found a commit condition, ironically, with the launch control sequencer that it didn't like. Basically, it could be a switch not flipped. It could be a temperature that's not right. It could be improper pneumatics. Like there's a bajillion different things that could be. So we'll see. This is its second scrub, isn't it? No, it's not. That's the first one for L70. bleep blooping in the code to get it to launch. Well, what ULA is doing right now, most likely, is, Delta 4 is going to offload its telemetry, right? It's you're constantly downlinking the telemetry. So ULA engineers are going to, first of all, and we heard the safing process right at the beginning, or right after they held, they're going to safe the vehicle, put the vehicle back into what's called a pre-launch configuration. Basically, they put it back in they go back a step in the manual and go get it back into the configuration that it was right before they triggered the auto sequencer to start. And from there, there's a couple of mission pathways that you can take. You can take the try to commit a launch again, right? Or you can start step 70, what they said is a detanking procedure. You could you go down the safing process. ULA chose to go down the safing process. Now, why? Why would you go down the safing process? How do you know it's not going to work again? Well, first and foremost, better to not roll the dice. If you go out there and you see that a bolt isn't tightened down all the way, yes, that's happened before. Not with Delta, but with Delta-derived rockets. Hey, if you know, you know. Sometimes it's just a bolt that gets detorqued. Sometimes it's something that stupid. We've seen that happen. We've seen NASA send a guy out with a wrench, tighten a bolt down, and then launch the rocket. Yeah, it's happened. Rocket science is not as abstract as you might think. Sometimes it's something like that. Now, like I said, what would cause that? Is that what's wrong with this rocket? No. I don't know. I don't know what's wrong with this rocket. It was enough for the launch director to say with conviction to go down the safing procedures route. So that either means it's something that has to do with the launch vehicle that would require somebody to go out to the pad and make a visual inspection. It's unlikely that it's software. My guess is it's hardware. Knowing Delta, there's probably like a switch that isn't flipped somewhere. But instead of sitting there with a fully tanked vehicle and sending a guy out to a fully tanked vehicle, which is what NASA did, still, that's pretty nuts. They decided to just launch tomorrow. It's much easier. Detank the vehicle, put the oxidizer in the hydrogen, put the liquid oxygen and hydrogen back in their tanks, safe the vehicle, go out and visually inspect it. Now, actually, because Tori Bruno, the CEO of United Launch Alliance, is pretty forthcoming about this stuff, we might actually hear what's wrong. If somebody asks him, That was basically what happened with SLS. Yeah, they had a bolt on their hydrogen plumbing systems detorque because of the freeze, because it froze. It froze and it detorqued the bolt and it started leaking. Have we had a Delta 4 Heavy that didn't scrub at least once? L71, I don't think scrubbed. That's the one with the octopus patch. But part of the reason why Delta has a hefty reputation of scrubbing a lot. Part of the reason why is because, well, once again, all of the hardware in all the systems for Delta were designed to support a 20 launch a year, 15 to 20 launches a year launch cadence, and they ended up at, even you go back 10 years ago at the height of the Delta program, arguably, you'd get maybe 1 or 2 launches a year. So this equipment has been sitting out there for a long time. It just sits out there and does nothing, which sucks. But yeah, I mean, say you have an automobile. What's the worst thing with a car that you can do to it? Save crashing it. Have it sit and do nothing. That's the worst thing for a car. Cars will last longer if you drive them around more. Fun fact. All the components are less likely to fail. Now, with that being said, there's not a demand that much to launch this rocket. So the demand drying up in the late 90s, early 2000s really is kind of the reason why A, Delta 4 carries such a heavy price tag, and B, why it always scrubs a lot. Hey, WD-40, thank you for the raid. Just barely not abandoned in place. It's not AIP, and I don't think it will be, Hibbit. I think that Slick 37 has another customer after ULA vacates, or their lease expires. Let me put it like that. Anyway, WD-40 with the raid. Thank you very much. I do appreciate it. Savvy had a 95-month resub in there. I started subbing before graduate. Now I'm a Blue Origin employee. How time flies. That's awesome, man. It's good to see you, buddy. Yeah, so Once again, the legacy and the chapter in the book of Delta lives on for another 24 hours. So, yeah. So, they wouldn't convert the Delta 4 Heavy pad for Vulcan? There's no need to, drummer. ULA made the engineering decision to retool Slick 41. The reason why, if you think about it, is because ULA anticipated an overlap. You're not just going to phase out one rocket and then bring a new rocket in. Arianespace has made that mistake, and they don't have any launch capability out of Kourou right now. So ULA, to hedge their bets against this problem, had an overlap in Atlas missions and Vulcan missions. So they made the decision, because Atlas does not carry as much of a heavy price tag as Delta, and because Slick 41 is using a mobile launcher, clean pad design, so you can roll the mobile launcher out and roll another one in, that it would be easier to reconfigure, and that's correct. Delta uses a fixed launch pad. The only things that can launch from this is Delta. Retooling this to get this to work with Vulcan would be a lot more complicated than Slick 41. Slick 41, you just build a new mobile launcher, and then just make sure all the connections to the pad are in the same spot, and then add provisions to the pad for methane. I say this like this is some easy thing to do. It's taken ULA 5 years to get all that figured out. But 5 years in the aerospace industry to make a launch pad launch two completely dissimilar architectures of rockets, it's actually pretty damn impressive, if I do say so myself. The rumor is that the launch will go ahead at 10:30 p.m.-ish local time. I highly doubt that, Double Dot, but if I mean, I'm not going to say that I wouldn't like to be proven wrong there. Didn't they have a Delta 4 design with 4 side boosters attached to the core? That's the Delta 4, it's a Delta 4-4 or Delta 5-4 medium, yes. This is Delta Heavy. Delta came in a bunch of different configurations. There was medium, there was 4 medium, there was 5 medium, there was 4-2 medium, 5-2 medium, 4-4 medium, 5-4 medium, and then there's eventually the evolution of that went to 5-2 and 5-4 medium plus. What do those numbers denote? The first number denotes the different size of the second stage. So Delta was originally supposed to have 2 different, well, not originally. Delta did originally have 2 different sizes of upper stage. They had a 4-meter variant and a 5-meter variant. What you're looking at right there is the 5-meter variant. So a Delta 4 medium 4, right, would be a single stick Delta with a 4-meter upper stage and a 4-meter fairing. And then there was Delta 4 medium 5. Delta 4 medium 5 is a single core with a 5-meter upper stage like that. 2 different types of payload fairings on top of that, and yeah, 2 different upper stages, single booster, the single booster core. The entire Delta architecture is based around the common booster core, CBC for short. With the CBC, with one CBC, you can make any different variant of Delta, just like Atlas. With Atlas, it's called the CCB, Common Core Booster. Delta is the CBC, Common Booster Core. Potato, tomato. I don't know how you remember all of this. I remember it because I have to. It's my purpose. Knowledge. Honestly, I like Vulcan. So Vulcan takes the best qualities of Delta and Atlas and makes it one vehicle. Yeah. They talked about that. They took the isogrid friction stir welding manufacturing process from Delta and applied it to Vulcan. Sure, you can copy my homework, just change the words around so it's not obvious. Random wait, is the Ford up and running? Which one? The 59? Yeah, the 59 runs and drives. It's just away for the winter. It's still cold and crappy up here, but I actually ran it today. It runs and drives. It's on the road, but it's covered up because of the work that I was doing on the other Ford. Yep. I'm working on the exhaust from this. I don't know if you could tell by what's in the pickup bed. But anyway, yep. 4 of those Hydrolox boosters that the Heavy has 2 of, not the solids. Never launched, but I thought I remembered seeing a design for one. 4 of the Hydrolox boosters. No. Nope. 4 solids, never 4 liquids, only 2. Delta 4 Heavy has 3 common booster cores, and that's it. Yeah, it could never launch with 4 of these things. No, absolutely not. Smug, you may have seen a fan render, or you may have seen some possible pathways for a 5 booster Delta. So like Delta Super Heavy with 4 CBCs on the outsides. It may have been a concept or something. Never implemented. Never got off the drawing board. Not even close. Really, Jens? He has a giant brain dedicated to what he likes. I bet he does not know when a Fiat Multipla was built. What, the minivan that was made in the 80s and the 90s from Fiat that looks ridiculous? It looks like a sandwich with wheels. What's that? I have no idea what that is. That being said, 5 booster Delta would have been a beast. It would have been something. Well, you stream Angara 5. Angara 5? Is that even on the books? Maybe? I don't even think they're going to stream it, but who knows? Can you imagine the Fireball in a Delta 5? That would be pretty nuts. Yep. Yeah, there were long-term evolutions that Lockheed and Boeing, McDonnell Douglas kind of wanted in the future. Yeah, here, Thomas. This was the Atlas Pathways Evolution for the Atlas rocket. This is where they wanted to go with it. And they did do it to an extent. Notice that this phase 2 thing right here, see this one right there? That looks a lot like Vulcan, doesn't it? Now, at the time when, oh geez, ILS. This is a very old picture, or very old piece of paper. It has ILS and the old Atlas logo on it. And it still says 1 or 2 RD-180s. No. Yeah. Aqualix, they wanted to switch to a 5.4 architecture with Atlas, and then eventually they would have went to an 8.4 booster tank. If the launch market was permitting. Yeah, this over here is okay. Yeah, and it also says Lockheed Martin. That's a good point. Basically, everything from here, from this thing over, happened except for that stubby thing. I don't know what that is. that was never made. Every rocket from here over, except for the stubby and except for that. Sorry, excuse me. Like these over here, those were all real. These ones were planned, but they never did it. Now that I'm actually looking at it. Those 3, actually, to be honest, Atlas Heavy never happened, but they could have done it. Let me put it to you like that. There's different phases of this stuff that came through and different ones that didn't. So what ULA really was planning on doing is taking Vulcan's upper stage and putting it on top of Atlas and making kind of an interim thing, right? And then they thought that they wanted to make Vulcan's core and put an Atlas upper stage on top of that. And then they never did that. And then they just made a whole new first and second stage and went with that and baselined it over here. So let me be clear. When I say everything over here has happened or was planned, this is all stuff that they were basically going to do or could have done. All right? This stuff over here, I have no freaking clue. I highly doubt we'll ever see anything like that. But who knows? You never know. So, now, a little bit of a clarification over here. This guy, Atlas Heavy. Atlas Heavy, the engineering was done. They could have done it. The pad has the provisions for it, believe it or not. It was never made. Once again, the launch market dried up, remember? Same exact problem as Delta. The Atlas was built to be able to do that. It could do that. You could bolt these things together. And the pad has the provisions for the right fueling umbilicals for that, if needed. That's what I meant when I said all this could have been done or has been done. I probably should have been a little more careful with my words there, but yeah, that's the idea. The stubby one looks like an ICBM. This thing I've never seen anything even remotely like. That's Vulcan right here. This one they actually did. But ULA did mess with concepts here of using the Atlas CCB with Vulcan upper stages. This was all planned and they never did it. But like that was, what I'm trying to say is I guess all this got off the drawing board at some point. These guys over here got off the drawing board. These were on the drawing board, and this is the one that actually got made. I don't know what the heck they're thinking about doing with this stuff over here, but I think if I'm gonna take one, I'd probably take this guy right here. That guy would be pretty sweet. But you know what the interesting thing is? That's basically New Glenn. It's a New Glenn class rocket. If you look at its payload capacity, 44 metric tons characteristic energy. 54 to 140 metric tons to Leo. That's kind of in the ballpark of where New Glenn's ended up. Don't get me wrong, New Glenn's is not derived from Atlas in any way, shape, or form. But, yeah, pretty interesting. Those Longboy fairings. They're probably not a total long fairing, dude, if I had to guess. There's probably a forward load reactor and an upper stage in there, and by probably, I mean there absolutely is. Yeah, I should have been better with my words there, saying everything from here over has kind of happened. Not really. That's not the right way to say that. Sorry. But, yeah, that's wrong. It kind of has, but it kind of hasn't. What payload is that long? A long one. Obviously. What are you, crazy? But anyway, Delta 4 did scrub. It's a 24-hour scrub. It's, yeah. And, yeah, well, we'll pick up the coverage again tomorrow. And go from there. A forward load reactor. Yeah, Dean. Okay. So, what's a forward load reactor? Okay, so say this peach Red Bull can. Oh yes. No, I'm not drinking it. I'm not drinking this stuff anymore. I stopped because it's not, yeah, not good for you. So, but I keep soda cans on my desk for when this comes up. So, rockets are an aluminum pressure vessel like this, right? So, what does a forward load reactor do? Some rockets, or some upper stages, I should say, aren't designed to be able to withstand the structural load of a launch, right? They're not designed to do that. So, what they do, we're using the Yingling can now. What rockets do is rely on residual pressure. They rely on residual pressure for structural integrity. That's why if a soda can is pressurized, so closed, you can stand on it, but you definitely can't stand on an open soda can. Because of this, the thing is very susceptible to being squished like that. So Atlas flies with a Centaur forward load reactor in the 500 series configuration. Now, what does that mean? So the fairing is outside of the stage. Say this Yinzer can right here is our Centaur upper stage. If they just had Centaur in the direct line, it would crush the thing. Because Centaur, the tank walls of a Centaur are about as thin as this soda can, believe it or not. Like I said, it's not called a balloon tank for no reason. So, what does a forward load reactor do? A forward load reactor is attached to the fairing that goes around this stage on an Atlas V. And it's basically a piece that looks like a C that connects the top of the stage to the fairing. Give me 1 second, I will show you exactly what I'm talking about. So right here, Centaur can't handle the loads of the Atlas. That's an Atlas 400 series. Of course I clicked on the wrong one. Right here. The Centaur can't handle the loads of having 4 solid rocket boosters and an RD-180 down here. It'll squish it like that soda can. So, forward load reactor. A load reactor is transmitting some of the longitudinal load that's being exerted on this from the high thrust to weight ratio here. It takes some of the structure to hold that Centaur tank up, especially with a payload on top, and transfer it to the fairings. The fairings are somewhat structural in this regard. Now, once again, why do you do that? Well, in this particular case, the Centaur can be crushed like a soda can under enough thrust, even with balloon tanks. The balloon tanks pop. If you squeeze a balloon enough, it's going to pop, right? You don't want that happening to your Centaur. This is, in fact, bad for it. Popping your rocket fuel tanks like a balloon probably not a good idea. I mean, something entertaining would happen, but yeah, you don't want to do that. So in Atlas's particular case, they had to install the forward load reactor to be able to put a bigger payload fairing on the vehicle. And if you're going to put a bigger payload fairing on the vehicle, you're going to carry a higher mass payload, you need more boom boom down the bottom to get it to fly. So they had to install the forward load reactor to deal with that. Now, there are other rockets out there. There are other rockets that have stage designs in them where the entire second stage is hanging on a load reactor. So check this out. Look at a Delta II. This is a Delta K upper stage, a hypergolic upper stage utilizing an AJ-10. Same engine as the Apollo service module, right? With a different expansion ratio for the technical people out there. So this is a Delta K upper stage. The entirety of a Delta K upper stage is hanging inside of the inner stage. Now, why do you do that? Same reason as the Centaur, but for a slightly different thing, slightly different application. The reason why they hang the Delta K upper stage in there is because if your stage is hanging inside of an inner stage or a payload fairing, instead of being pushed up from the bottom, you can make your stage a lot lighter. Now your stage is being pulled up instead of being pushed up. And because it's not in the mainline load of the first stage, i.e. all the accelerated forces are being moved through the inner stage up to this adapter and then up to the payload fairing, right? Because load is being transmitted around the tanks, you can make your second stage a lot lighter because now it doesn't have to withstand the full force of that first stage pushing up on it. It's being pulled instead. Sometimes it's easier to pull than to push, right? Neutron is also doing something like that. So yeah, that's what I mean when I say a load reactor. Load reactors are things that you can do to basically improve your mass fraction of your upper stages by basically hanging them inside of an inner stage instead of pushing up on them like a conventional rocket. Does it take the upper stage out of the load path or just reduce the load on it? It takes it out of the load path completely. Completely. Think about it. It's hanging. I mean, you're still going to have to move that mass, obviously. Physics doesn't change, but... So, think about it like tensile strength. Not tensile strength. Yeah, tensile strength versus compression strength, all right? To get something to be pulled and stay together is a lot easier than pushing up on it, right? We're talking about concrete versus Kevlar here, or carbon fiber. Yeah. Somebody missed the memo on that one once. Didn't end well. Carbon fiber is not really good at compression. It's very good at tension. It's very good at resisting tension. Yeah, someone missed the memo on that one. Like a chandelier in a cruise ship. Yeah, I suppose if you want to look at it that way, Chrome. Yeah, sure. Yeah. So you can afford to make your second stage out of lighter materials because it's a different material that could potentially be a lower mass and give you a better mass fraction, right? Would be less susceptible to tensile strength over compression strength. Now, in the instance of Atlas V, they didn't want to change the Centaur design. They wanted to keep the Centaur design. No use re-engineering the wheel, especially the Centaur. It's about as good as you can get in terms of mass fraction. So they designed Atlas V kind of around that. That's what happened.
Discovery,
Hey,
go at throttle
Marco,
up.
13-month resub. Thank you very much. But yeah, it's very interesting. If you look at a Delta K, the entire stage is hanging. See? It's hanging from, believe it or not, it's hanging from the payload attachment fitting. The PAF is what's carrying your structure here, which is weird. Yeah. PAF is attached to this aft skirt right here with a bunch of struts. Interesting thing, while we're talking about Delta, is that when Boeing and McDonnell Douglas, when Delta IV was being engineered, they started implementing the Delta cryogenic second stage, and they implemented some lessons learned from this. Guys, take a look at a Delta cryogenic second stage. What can you tell me about it? Oh, that's weird. That's also a very small picture. What does that look like? When the stage separates, does the structure remain with the second stage? Yes. Now look at that. Your liquid oxygen tank is hanging. This is a partial load reaction. The stage are partial load. It's a partial load reactor. The hydrogen tank is carrying all your structure. But this affords you your oxidizer tank to be super freaking light. All the oxidizer tank has to do is be able to carry the load from an RL-10. Carrying an acceleration load from an RL-10 is not very much. RL-10s only make 100 kilonewtons of thrust. So there's not a lot pushing back here. So you don't need to design this. You can basically save mass here by not making the tank walls on your oxidizer stage, the oxidizer tank on your second stage here, not putting them in the mainline structure. This is what SLS does. Delta 4 does that. There's one of these sitting on the pad right now. We just watched it scrub. Yeah, Delta upper stages are quite big if you look at the dude standing next to it. Even future variants of SLS will carry something like this, the Exploration Upper Stage, the EUS for short. Huh, what does that look like? That's weird. Same idea. This affords you, especially with SLS's designs, this affords you to be able to make your LOX tank not necessarily be able to withstand a lot of compression, but the tensile load of your LOX tank needs to be a lot higher than the compression load. I'll say this once, I'll say it again. This affords you to be able to make your liquid oxygen tank out of something way lighter. Not aluminum, carbon composite, carbon fiber. Because carbon fibers and carbon composites are way less susceptible to tensile strength. Or, yeah, tensile load. They have higher tensile strength. They basically can be stretched. Carbon fiber resists stretching for the same reason that, like a Chinese finger trap, if you try to pull away, it gets stronger and pulls your finger out of socket, and that really hurts, and I hate doing that. Same idea. It's knitted, carbon fiber is knitted together, and if you pull on it, it gets super strong. Very, very high tensile strength. But if you push on it, Chinese finger trap, you push it together, your finger slips out. That's compression load. So, think of in the future, you have a version of SLS with a carbon fiber liquid oxygen tank. That's a lot of mass dumped that you don't need on your second stage. The EUS will give you an insanely high mass fraction with a carbon fiber LOX tank. You'll be able to, you're saving a bunch of mass off of this, and that's more mass for payload. NASA and Boeing are working on this right now, by the way. How did you become so knowledgeable on so many topics relating to rockets? Curious because I want to learn more. I read about rockets every day on social media. I read textbooks, aerospace engineering textbooks, little rocket. What do you want to know? Like, if you really, all right, I wouldn't suggest going and buying like an aerospace engineering textbook. Those are expensive. What I would suggest is just go on Wikipedia and start reading about rockets. Is all the information on Wikipedia right? No, but it's good enough. Good enough to get the point across. That's a good way to get your feet wet. Just go start read about the space shuttle. Read the wiki pages. That's where I started 14 years ago. Yowza. Is that final upper stage deorbitable? The exploration upper stage, deorbitable? Jens, we're talking about a rocket that, the EUS is supposed to be on a rocket that's designed for lunar exploration and architecture. I don't know where your mind's at to think that this rocket that's designed to shoot this thing off at the moon is like, oh, well, is it deorbitable? No. You could, depends on the mission, but, you know, what you're asking is, you know, if I'm driving around in a school bus, you're like, oh, can that tow an RV? I'm like, it's a school bus. And you're like, yeah, I know. Could you tow something with it? I mean, yeah, I guess. It's not really what a school bus does, but it's got the torque to be able to do it. You could put a trailer hitch on the back if you really wanted to, but it's a school bus. Toto, nice. So it ain't coming back. It could. It could. It depends on what you're doing with it. Could a school bus tow something? It could. Depends on what you're doing with your school bus. You know what I mean? Like, yeah, it depends on the mission. It will most likely, with the EUS, you'll be dealing with what's called heliocentric disposal. Launch it into the sun. That is a lot cooler than what it actually is. They launch it into solar orbit or heliocentric orbit because the technical name for the sun comes from ancient Greece, Helios, sun god. So orbits that are around the sun in orbital mechanics are called heliocentric orbits. So heliocentric disposal. The plain English way of saying that is launch it into the sun. But it's not actually going to get anywhere near the solar corona. It'll just be stuck in an orbit around the sun like Earth is. It'll be in a similar orbit around Earth because this thing will shoot something off to the moon. It'll separate, and then instead of stepping on the brakes at the moon, it'll just keep going. Or you could smash it into the lunar surface if you really wanted to. Yeah, sure. Smuck, there's wrong stuff on Wikipedia. Wrong stuff that is verified, which I think is hilarious, but I won't speak to it. There's wrong stuff on Wikipedia. It's a good place to start, but you're not going to go get your education from Wikipedia, okay? It's a good place to get your feet wet. You want to really get into this stuff? Rocket Propulsive Elements by Sutton. That RPE is like the Bible for rocket engineers. Mm-hmm. Heliocentric disposal does sound pretty cool. Should the name of a track in your supersonic retro... It should be a name of a track in your band Supersonic Retro Propulsion. Yeah. All right. Well, guys, let's jump back over to workers, shall we? If the launch bug is still itching you, we have a launch at 10:30 tonight. That's Starlink Group 718 out of Vandenberg. That is in approximately 7 hours. So I got you for 7 hours. 7 hours of playtime. No, we're going to play the game. We have to go back to... We're